Welcome to structural analysis 2. This is the second part of a previous problem which is based on numerical analysis of a frame by cantilever method. In a second part, we are going to for the lower story. For that, let's cut this frame from the middle of a column of a length 4.5 meter and the find out the forces for the members which is connected to the joint F, joint E and joint D. Now from the upper story we know the forces in the member which is common for the F and G joint. So in a upper story we consider the joint GHI, and from that we know the member forces for that member which are connected to that but connected to the joints. Now the members which are common for the joints, uh, their forces we know. Now let uh, move the further. Now here the FBD of lower story is shown, and the for that the structure or frame is released from the node 8, 9, 10. You see the at the joint where we at the nodes where we cut the frame, there are two forces are acting. One is a shear force and second is a axial force V or and H. And there will be external forces will be there 25 and 50 kilonewton respectively at G and F joint. Now the let call these shear forces H8, H9 and H10, and these are the axial forces V8, V9. Let take it downward. Both are in a downward direction. V8, V9, and V10 in upward direction. And shear forces are we are taken in opposite of these external forces. So summation, if we do the summation of horizontal forces, so it will be H8 plus H9 plus H10 is equal to 25 plus 50 kilonewton. So that is one equation. And now take a moment about P. So first is a V8. This one is a V8. So V8 and the distance is 4.875. So and it will rotate about the P in a anticlockwise sense. So that's why positive. The next is a V9, and the perpendicular distance is 0.375, and which is rotate in a anticlockwise sense. Take it downward. So positive V9 into 0.375. Next is a V10 acting in upward direction, and if we rotate, it will rotate in anticlockwise sense. So V10, it is V10 into this distance is 5, 6 to 5. And the next forces, horizontal forces. Now there are horizontal forces which are acting at the same level and in the toward the left hand side. So it's the distance, perpendicular distance will be uh, 1.5 plus 3 become 4.5, and it will rotate about P point in a clockwise sense. So it become minus in bracket H8 plus H9 plus H10 into this perpendicular distance 4.5. So toward right side it become positive. So H8 plus H9 plus H10 is into 4.5. By simplifying, now also the there is a 50 kilonewton force is also there. This 50 kilonewton force, but 25 is passing through the point P, so its moment will be 0. So 25 will rotate about P in a anti-clockwise sense. So positive 50 into 3. So by taking right hand side it become minus. So minus 50 into 3. So this is the equation which is developed by taking a moment about P point. Now, as per assumption, axial forces in the column is proportional to its distance from the centroid and area of a column group at the that level. Or we can say like this ratio stress to distance from the CG of each column is same. That ratio is same. So here same thing is mentioned here. First is taken first column. Axial force is V8 divided by area means stress, and the distance up to the this centroidal axis is taken 4.875. Next column is next column, and its area is 2a, and the axial force is V9. So V9 divided by 2a into this perpendicular distance is 0.375 up to the centroidal axis. Next column is last one, and axial force is V10. V10 divided by area means stress, and the perpendicular distance up to the centroidal axis is 5.625. So by simplifying this, we have a equation of a V9 and V10 in term of a V8. Now put this V9 and V10 in the moment equation. So we have V8 as it is V9. Now put it this V9 0.15 0.154 into V8 into 0.375, it become 0.058 V8. Now next is V10. This is V10, not V5. So instead of this V10, let's put 1.154 V8. So here you see, by multiplying this 1. Here this value, by multiplying this 5.625, it become 6.491 V8. So all terms are in term of V8. Okay, and the right hand side, now there are H8, H9 and H10 is equal to 25 plus 50. So it become 75. So put that value here. So 75 into 4.5, it become 337.50 minus this 50 into 3. So by simplifying, we have 187.50. So we will get V8. So once we will having a V8 value, which is V8 is equal to 16.42, put this V8 value here, we will get V9 and V10. V9 is 2.53 and V10 is 18.95. Now here the FBD of all joints are mentioned: joint G, joint H and joint I. So these forces we know from the upper story calculation or from the previous video. Now the next joint, corresponding joint is F. So whatever the forces here, H3 and V3, same forces you have to show here, but only their direction you have to change. You see the magnitude we keep same, only we change the direction. V3 acting down, we keep it up. H3 acting toward the left side, we take it right side. So in the same way you mention at each corresponding joint. Okay. Now let consider F joint first. Now these shear force and uh, uh, their axial force, those are the unknown. We taken V6 upward direction and H6 toward the uh, left hand side, and V8 we know from the previous calculation, 16.42 down. V8 we don't know, we taken it toward the left hand side as a H, sorry, H8 we don't know, so we taken it toward the left hand side. Now apply, let first solve this joint F. joint F, summation Fy is equal to 0, upward positive, downward negative, 0.3283, this one V3 upward, so positive, then the plus V6 and minus this downward minus 16.42 is equal to 0. So by simplifying, we have V6 is equal to 13.42 kilonewton, which is acting down. Now take moment about F. Now the axial forces will create zero moment. So 50 will not give any moment, H6 will not give moment, V8 will not give moment, and V3 also will not give moment because they are passing through the F point. The forces which are perpendicular to the member, that only we have to consider. So H8 will rotate in a clockwise sense. So minus H8 into lever arm 2.25. Now next is a H3, which is rotate in a clockwise sense. So minus 4.925 into 1.5, and then the V6 which will rotate in anti-clockwise sense. So plus V6 into 2.25, V6 is 13.40. So putting so is equal to 0, we will get H at 9.86 kilonewton. Now do the summation Fx, H3, H6 and H8 and 50 will be appear in summation Fx. So let's take minus H6, these are the sign convention, uh, left hand side negative, right hand side positive. So minus H6, then plus 50, then minus this H8 minus 9.86, and this H3 is plus 4.925 is equal to 0. So by simplifying, we have H6 is equal to 45.065 kilonewton. Yet consider next joint. Now these forces you have to apply in opposite sense of previous joint. V6 is up, H6 is toward the left hand side. So apply in opposite direction. Keep magnitude same. The forces here we don't know. Consider upward V7 and H7 toward the uh, left hand side. These are the forces. This is in downward direction. Make it correct. V9 2.63 and H9 toward the left hand side. Now these are taken from the upper story joint. Now apply the summation Fx, summation Fy and moment and find out the forces. Let first do the summation Fy, upward positive, so minus and downward negative. These are the sign convention. So minus 13.14 V6, then upward V4 0.506, then V7 plus, and downward again this one is a downward minus 2.53 is equal to 0. By simplifying, V7 is equal to 15.164 kilonewton. Take moment about E. So the axial forces will create the zero moment. Those are along the member. Those will pass through the joint E. So only the forces which are perpendicular to the member, that only we have to consider. So there are four forces. So take one by one. 13.14 lever arm is 2.25, and it will rotate about E in anti-clockwise sense, so positive. Then V9, V9 perpendicular distance, this one 2.25, it will rotate in a clockwise, so minus V9 into 2.25. Next is a V7, perpendicular distance is 3 and rotate in anti-clockwise sense, so positive 15.16 164 into 3, and last one is H4 which rotate in a clockwise sense, so minus 12.503 and lever arm is 1.5 is equal to 0. By simplifying, we have H9 is equal to 25.023 kilonewton. Then do the summation Fx. These are the sign convention, toward the right positive, toward the left hand side negative. Uh, 45.064 is a horizontal force H6 toward the right hand side, so positive. Then H7 toward the left hand side, so minus H7, then H9, which is uh, toward the left hand side, so minus 25.023, and next one is H4 toward the right hand side, so positive 12.503 is equal to 0. So by simplifying, we have H7 is equal to 32.54 kilonewton. This one is the last joint. Now whatever these forces are taken from the previous joint, E joint, only you, this one is acting up, so here you take downward direction. This is acting toward the left hand side, take here you take toward the right hand side. Magnitude you keep the same. Now here the H10 is acting toward the right hand side and V10 is acting toward the upward direction. And the forces here which are taken from the previous calculation or for upper story joint. Now do the summation fx, because here H10 is unknown only. So do the summation fx, and these are the sign convention, right side positive and left hand side force we have to take negative. So 32.54 positive right hand side, and then 7.573 positive, and H10 which is taken toward the left hand side, so minus H10. By simplifying, we will get H10 is equal to 40.113. So we having all forces which are in the member of a particular joint, that means joint F, E and D. Next one is a bending moment diagram. So to draw the bending moment diagram, you have to consider the axial forces and the half distance of a beam. Now the half distance of a beam is 2.25 meter, and the axial force is 3.283 for this beam. So this axial force into perpendicular distance, you will get this bending moment 7.39. Okay, same way for each member you do in the same way. You locate the axial forces, which we know from the joint calculation. These are the axial forces for this mid joint. Into the half distance of a member, you will get the corresponding bending moment diagram. Only you have to take, if this arrow is up, here you take in a downward direction. Here the arrow is down, here you take in upward direction. So likewise, you have to show for all the uh, member. For the column also, you have to consider the axial force. That means not axial force, transverse force, or you can call it as a shear force. These are the shear force. You make it. You note down this. These are the shear force, not axial force. So the for column, these are the shear forces 7.573, and they are taken from the joint calculation, and the half distance of a column that you take to find out this bending moment of a column. So 7.573 into half distance of a column, you will get 11.36. So now you see this arrow is toward the, this arrow is toward the left hand side, so show the moment toward the right hand side. Now this arrow is toward the right hand side, show the moment toward the left hand side. So likewise you have to show for all the column. Okay, so this is about the bending moment diagram. Thank you.